Welcome to this explainer. Okay, today we are getting into something seriously cool. The hidden, professional techniques you can use to unlock your modern processor's absolute maximum potential, all directly from the motherboard.
So, did you know your PC might actually be hiding its true computing power right now? Most rigs ship with standard factory defaults designed for broad compatibility out of the box. It's kind of like buying a high-end sports car, but realizing the dealer left a speed governor on the engine. Sure, it keeps things totally safe and easy for everyone, but you are leaving significant, completely free performance just sitting right there on the table. We're talking about untapped speed and efficiency that you've already paid for, just waiting to be unlocked.
Here's our blueprint for today. We'll start with the hidden potential, then move into the engine room, go beyond the core, make sure we're playing it safe, and finally, wrap things up with measuring success. Let's get right into it. Starting off with Section 1, the hidden potential, decoding the BIOS and UEFI. Let's figure out exactly what's holding your hardware back before Windows even boots up.
This right here is where the magic starts. The BIOS, or UEFI as it's known on newer boards, is the fundamental firmware that wakes up your hardware. The absolute second you hit the power button, the BIOS acts as the ultimate gatekeeper for your CPU, RAM, and GPU. It handles all the hardware initialization, it runs the memory training, and it detects your storage. Mastering these menus is the rock-solid foundation of any real performance upgrade, because if the foundation is limited, your operating system is going to be limited too.
Moving right along to Section 2, the engine room, unlocking your CPU and RAM. This is where we hit the highest impact tweaks for your processor and system memory. So, modern Intel and AMD chips actually have these incredible dynamic scaling features baked right into the architecture. By tweaking some very specific settings like Intel's Turbo Boost, AMD's Precision Boost Overdrive, or dialing in your curve optimizer and adaptive voltage limits, you are effectively wiping out those artificial factory limits. You're giving the memory controller and execution units the green light to scale up their clock speeds based on their actual thermal headroom rather than being changed to a super conservative baseline.
When you put factory default settings up against optimized configurations, the difference really just comes down to efficiency. Factory settings play it super safe with conservative power limits that prioritize universal stability over raw speed. But when you optimize, you can leverage tools like undervolting to hit higher turbo multipliers and way better efficiency. That means you can actually get your processor running significantly faster while pulling the exact same amount of power. It's a total win-win.
Now, a blazing fast CPU doesn't mean much if it's sitting around starving for data. That is where RAM profiles step in. If you haven't enabled XMP, EXP, or DOCP in your BIOS, your expensive DDR4 or DDR5 memory is literally stuck running at slow, default baseline speeds, which severely bottlenecks your CPU's memory controller. Just by flipping on these pre-configured, rigorously tested profiles, you instantly unlock your RAM's advertised high-speed frequency and lower its latency, feeding data to your processor exactly as fast as it demands it.
All right, on to Section 3, beyond the core, storage and GPU tweaks. We've got the CPU and memory dialed in, so let's clear out the data bottlenecks in your storage and graphics.
This feature is just brilliant in its simplicity. Resizable bar is a PCI protocol that basically lets your CPU access your graphics card's entire memory buffer in one go. Without it, the CPU has to access GPU memory in these tiny, inefficient 256 megabyte chunks. Turning on resizable bar along with above 4G decoding is basically like taking a single-lane dirt road and expanding it into a massive, multi-lane superhighway for data traveling between your processor and graphics card. And hey, that data highway shouldn't just stop at your GPU. Getting your storage protocols properly configured in the motherboard chipset menu, make sure you're actually using all that massive bandwidth you paid for. We are talking about forcing your NVMe and PCIe lanes to their absolute max Gen 4 or Gen 5 speeds, double-checking your AHCI or RAID setups, and ensuring SSD trim support is actually active. These peripheral tweaks are the absolute secret sauce to lightning-fast boot times and instant application launches. Which brings us to Section 4, playing it safe. Cooling, power, and BIOS updates. Before you permanently lock any of this in, we really need to talk about protecting your hardware and maintaining system stability.
You always want to kick off this whole optimization process by updating your firmware using a safe USB flashback. Manufacturers are constantly dropping updates to improve memory training and CPU compatibility. It's pretty straightforward. Download the file to a USB, reboot, mash that delete or F2 key to get into the BIOS, use the built-in flash tool, and, this is the big one, reset to default CMOS before you apply any tweaks.
Think of it as wiping the slate completely clean. It just guarantees the best hardware compatibility and security from the jump.
Now, as you start tinkering, please avoid these common pitfalls. Cranking up manual, unsafe CPU voltages without dialing in your fan curves, or thinking about VRM airflow, yeah, that's a one-way ticket to skyrocketing temps and a totally unstable system. And like we talked about, leaving those memory profiles disabled or skipping your mandatory stress testing basically means you're just guessing at what your system can do instead of actually proving it.
And that really builds into the golden rule of tweaking. Successful optimization isn't just about chasing raw speed. It is about finding that perfect sweet spot between peak processing power and absolute 24/7 reliability. True stability requires a lot of patience. You want to make small, incremental adjustments, run your stress tests, keep a close eye on those temperature sensors, and find your hardware's safe equilibrium.
Okay, finally, Section 5. Measuring success, benchmarking the real-world payoff. We built the blueprint, now it's time to see what we actually achieved.
Look, you can't improve what you can't accurately measure, right? So you're going to want to grab these industry-standard tools to verify your baseline metrics before you tweak and then again after. CPU-Z and HW-Info are amazing for real-time telemetry on your voltages and clocks. Cinebench and Geekbench will absolutely push your CPU rendering to the limit. 3D Mark handles the gaming side of things, and heavy hitters like Prime 95 and MemTest 86 are the absolute gold standard for proving your system is 100% stable.
And honestly, the results speak for themselves. Looking at a gaming comparison, unlocking those CPU frequencies and flipping on resizable bar gives a massive boost to your frame rates. By lifting those factory constraints, your GPU is fed data so much faster, giving you way higher sustained performance across the board without all that annoying stuttering.
But it's not just for gamers. If you're a workstation pro using heavy apps like Blender or Premiere Pro, these exact same tweaks will drastically slash your rendering times. Because your multi-core execution units aren't artificially starved for power anymore, tasks like file compression, AI workloads, and video rendering finish up significantly faster. You are quite literally buying back your own time.
To sum it all up, the immediate, real-world benefits across the board are pretty wild when you just properly configure that motherboard. We're talking faster Windows boot times, higher sustained clocks under heavy loads, noticeably lower system latency, and much smoother multitasking. It entirely transforms a sluggish, out-of-the-box PC into a highly responsive, finely tuned machine.
And that wraps up this explainer. It really leaves us with one final thought. Why on earth would you settle for factory constraints when maximum performance is literally just a keystroke away? You've got the tools, you understand the engine room, and you know how to do it safely. It is time to go unlock the true power of your PC.